Okay, YouTube, in this video we're going to explore the slope of lines further, specifically parallel and perpendicular lines. But we're going to start by considering this graphic that I have here. And I just kind of want to bring up a point, but it says that we have here the number of U.S. adults ages 18 and older living alone. And you can see that we have two different sets of data here, one for men and one for women. And this is for our dependent variable, where we have number living alone in millions, and then the year down here on the independent variable axis. So what I want to do is basically this. I want to answer how do these two lines compare? And what I notice right off the bat is that men are fewer in value than women at any given time for this entire set of data. But also that men, if you look very carefully here, as a matter of fact, their graph is just a little bit steeper than the graph for the women. And we could actually show this by finding the slope of each data set, okay? And that's kind of be the key characteristic here. But what I want to do is I want to say, well, would these, if we were to allow this to continue at these rates, ever intersect? And they would eventually down the road. Men, it looks like, would overtake the women because of their higher slope. So my question really becomes this: what would have to be true about the slope of each of these graphs so that they would never, ever intersect? And that'll be the first stop we make today, and that'll be with parallel and perpendicular lines, but specifically parallel. So let's go ahead and talk about two parallel lines. We would say that two non-intersecting lines that lie in the same plane are said to be parallel. Of course, that's what we refer to as parallel lines. So we say if two lines do not intersect, then what we'll say is the ratio of the vertical change to the horizontal change is the same for both lines. That is to say, basically they have the same steepness. And if they have the same steepness, then they have the same slope. So the very, very first thing we want to admit here is this. Excuse me. Two non-vertical lines have the same slope if they're parallel. So if two non-vertical lines are parallel, then they have the same slope. And also this, if two distinct non-vertical lines have the same slope, then they are parallel. This is a bijection both ways, okay? Now, the one exception here is this: when we discuss slope, we say two distinct vertical lines, that is, two lines that aren't the same vertical line, they'll both have undefined slopes, and then they're parallel. So you can kind of say that they have the same slope, even though that slope has no value. It's just undefined, okay? So what we want to do is kind of take a look at this first example. It says write an equation of the line passing through this point, negative 2, 5, and parallel to the line whose equation is y equals 3x plus 1. And what I'd like to do is express this equation in point slope and in slope intercept form. So the first thing I want to kind of indicate here is that it says write an equation of the line, which would indicate that we are going to need to use our point slope form of this line. So the request here was that we make this line, in particular, that's going through negative 2, 5, parallel to this line right here. And so what we've just discovered is that if they're going to be parallel, then they have to have the same slope. And I notice that the slope of this line here is 3. So to write the equation of a line, we need two things. We need the slope, and I know that I want it to have the same slope as this line. Also that I want it to go through this point, negative 2 comma positive 5, which this will be our x1 and y1 for this equation. So we'll say x1, y1, our fixed point here is going to be the point negative 2 comma 5. So now we're just going to run some substitutions. We say y minus our y value here, 5, is equal to our slope value, which we want to be 3, times x minus x1, where our x1 here is a negative 2. So we're going to go ahead and simplify this because we wanted it both in point slope forms, which congratulations we have, but we're going to distribute and simplify as well. So we have y minus 5 equals 3x plus 6. And then we're going to add 5 to both sides. We say add 5, add 5. And what we get is this in slope-intercept form, 3x plus 11. So now, I'm fairly certain we'll be able to fit both of these on this xy coordinate plane over here. But if we graph the first line, which had a y-intercept of 1, and then a slope of 3, so it would rise 3, run 1, it would have been this line right here, roughly, okay? And so I'm kind of trying to sketch this to the best of my ability here. But the other line here had a y-intercept 11 and also a slope of 3. So I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Look at that. 11 units. And since I have difficulty going up 3 and over 1, I'm going to go down 3 and back 1. I'm going to say, look what happens when we graph in both of these equations here. If my sketching skills are fairly okay here, we would say that these two lines are indeed parallel because they have the same slope. So the last thing we're going to confront in this video happens to deal with perpendicular lines. Okay, so what would be true about perpendicular lines? Well, I'm going to go ahead and throw a perpendicular line over the top of both of these. And since they're both parallel, we would have some perpendicular line as being at a right angle with both of these lines right here. So one thing I want to mention is this. If you have an increasing line, a positive slope line, then its perpendicular line has to have a negative slope. And vice versa. If this line here is decreasing, has a negative slope, then its perpendicular line is going to have a positive slope. The only exception is with vertical and horizontal lines with respect to one another. But that being said, it is not just okay to just say, well, because if this line here, for example, has a slope of 3, if I want it to be perpendicular, I'll make it negative 3. And we could see this easily. If I had, say a line here with a slope of 3, this would be, some line with a slope of 3, like that right there. If I were to have gone down 3 and right 1 and said, okay, well, is this perpendicular to this line right here? It has a slope of negative 3. You can see that it's certainly not perpendicular. So the other stipulation is going to be that not only is it negative and positive, that they're opposites, but that they are opposite reciprocals of one another. So this graphic right here, you can actually see we have some line AB, and we have some other line A prime B prime, and you can see that if the slope of A here, we say the slope is positive C runs D, we say C over D, then in order to get a perpendicular line or slope of a line that is perpendicular to this given line, we actually have to say it's opposite, so it's negative, and also D over C. So you can see that these slopes are negative reciprocals. So let's talk about the formal definition of perpendicular, and then we'll talk about what we could just say in English to mean the same thing. But if we say if two non-vertical lines are perpendicular, then the product of their slopes is -1. And that is to say, if I were to take negative D over C over here on the left times C over D, you could see that we're going to get a negative value, and of course these all cancel out. They're reciprocals, so we get -1. So that's essentially what first two of these bullet points mean here, and then this third one basically says a horizontal line with a 0 slope. It's only going to be vertical to a vertical line having an undefined slope, okay? So an equivalent way of stating this relationship where their product of their slopes is -1, okay, I get that, is that one line is perpendicular to another line if it has a slope that is the negative reciprocal of the slope of the other line. So that is to say, if we have a line with a slope of 5, or like 5 over 1, then we say -1 over 5 is just perpendicular to it. Likewise, -3 over 4, okay, well, positive 4 over 3, that'll be perpendicular. So for this last example, we're going to run through a couple letters here, but the first one just says, find the slope of any line that is perpendicular to this line who I've given us in general form. And so for letter A here, I'll just kind of indicate this is letter A. The very first thing that I'm interested in doing is ascertaining what is the slope of this line. So what I'm going to do is I'm going to move all of these non-y terms over to the other side. I get -x plus 12 on the right side. I'm going to divide everything by this positive 3. I want to get this in a slope-intercept form. So we can see here that y would be equal to -1 divided by 3 with the x on the side, and then positive 12 over 3 would just be a 4. So we say here's our line right here, and we can easily indicate that the slope is -1/3. So we say a perpendicular slope to the line that you gave us, perpendicular slope, it would have to be equal to this, positive 3 over 1. I'll even put a positive just to be explicit here. So now for letter B, what I want to do is, just like we did on the other one with parallel lines, I want to write the equation of a line passing through a given point. So I am going to indicate that we already have some point on this line, x1, y1, but then we say perpendicular to the line whose equation is this right here. And so the thing I want to mention is that we have already, this is the same equation that I used over here, okay? We've already found the slope of something that would have to be perpendicular to it. The thing I want to point out though is this: to write the equation of a line, we just need two things. We need the slope, and we need a point. -2, -6 here is indeed our point. So we're going to get y minus y1 equals m times x minus x1 using our point slope formula. We know that y is equal to -6 if and only if our x value is -2, and we desire to have a slope of 3. So simplifying this, we get y plus 6 equals 3 times x plus 2. We'll go ahead and distribute this, and then we'll isolate our y next. So we have y plus 6 equals 3x plus 6, and then I'm going to subtract 6 from both sides of this. And I'm going to see that we have here y equals 3x, which would be indeed perpendicular to this given line and go to the point -2, -6. Cheers.